Welcome to The Explainer. Last year, it felt like the entire tech world was completely obsessed with prompt engineering, right? Everyone thought that just typing the absolute perfect instructions into an AI was the ultimate future-proof skill. But let's be real, the industry is already moving on. The next 5 to 10 years, they don't belong to the people who can write a clever prompt. They belong to those who master context engineering. And the absolute best part of all this is that you don't need to know a single line of code to do it.
Okay, let's dive into this. Here is our roadmap for how we actually evolve from simple AI queries to building autonomous digital workers. We've got 1, the paradigm shift, 2, the context window, 3, the 7-layer agent stack, 4, context failures, and 5, the right framework.
All right, Section 1, the paradigm shift, moving beyond prompting.
So we are officially moving away from traditional hardcore coding. And honestly, we're even moving beyond basic prompt engineering. To really understand where we're going, we kind of have to look at where we've been. Prompt engineering is just fundamentally static. You give a model a single query and it spits back a single output. It's totally focused on how you word a question, garbage in, garbage out. But the problem is it completely breaks when you try to scale it up or when your workflows dynamically change. Context engineering, on the other hand, is completely dynamic. It's the actual discipline of architecting and curating the exact tokens, tools, and history an AI needs in real time. This is what allows for multi-step tasks and looping subagents that genuinely work together to accomplish really complex goals.
And this brings us to the biggest, most glaring flaw of prompt engineering. The source material perfectly compares this to the movie Gajini, basically a severe case of amnesia. With basic prompting, the AI forgets literally everything the moment you close the chat. You start a new session and it has absolutely no idea what you talked about yesterday. Zero memory. Context engineering actually fixes this by dynamically managing what the AI remembers and exactly when it needs to remember it.
Moving on to Section 2, the context window, the finite box.
So how do we actually manage that memory? I want you to visualize this as a giant physical whiteboard, or maybe like the RAM in your computer. It's a finite block of memory, and it's measured in tokens, where one token is roughly 3/4 of a word. When you ask an AI agent to do something, it has to assemble its instructions, its identity, its available tools, and its past history all on this one single whiteboard at runtime. Now, in the past, this window is pretty small, maybe around 200,000 tokens. But today, models like Claude Sonnet give you a massive 1 million token limit. Now, seeing that massive 1 million token limit, a lot of people make a really dangerous assumption. They think, oh, great, I'll just upload thousands of pages of my company's history, every single old document, and the AI will just figure it all out. But hold on a second. Why is the bigger context window actually not always better?
Because if you completely overwhelm that whiteboard with irrelevant, unspecific data, the AI's performance rapidly degrades. It loses the high signal tokens. It essentially can't figure out what's actually important right now. And this leads directly to hallucinations. The model literally just starts making things up because it's drowning in all this noise. You absolutely have to curate exactly what goes into that finite box, because if you don't, your digital worker becomes entirely unreliable.
All right, Section 3, the 7-layer agent stack, mechanics of a digital worker. And this brilliantly illustrates how we structure that information efficiently. Let's look at the digital mechanics using a real-world analogy. A waiter. Let's say we're building an AI agent to replace a human order taker to save on costs. Layer 1 is the user input. The customer calls up and orders a large pizza. Layer 2 is the system instruction. The AI checks its prompt and realizes, right, my identity is Tony, I'm the pizza order taker. Layer 3 is retrieve facts. Tony checks the current menu just to make sure large pizzas are actually available. Layer 4 is tools. Tony uses the API to shoot a message over to the kitchen. Layer 5, short-term notes. Tony jots down on his mental scratch pad, okay, the customer's dining in today. Layer 6, long-term memory. Tony pulls from the database and realizes, oh wait, this customer was here last week and they always order dessert. And finally, Layer 7 is the output schema. Tony formats his response and says a friendly goodbye. Every single digital worker out there, whether it's an accountant, a marketer, or Tony the order taker, functions on these exact 7 layers.
Which brings us to Section 4, 4 fatal context failures. What goes wrong?
So what happens when we mismanage that finite whiteboard we talked about earlier? What happens when our digital waiter or our chartered accountant gets totally overwhelmed? Well, you're going to experience 4 fundamental mistakes that will completely break your digital worker. If you don't manage the context window, you get context poisoning, context distraction, context confusion, and context clash. Let's break these down quickly. First up is context poisoning. This is when a false or just unverified piece of information sneaks into the context window and corrupts all the future outputs. Imagine you run a boot camp, right? And you've recently increased your fee to $15,000. But somewhere deep in the old files you uploaded to the AI, it still says $10,000. Because you didn't verify the output before injecting it, that one outdated fact poisons the whole system. Every time a new student asks for the price, the AI confidently gives them the wrong outdated fee, and that is literally costing your business money.
Next is context distraction. This happens when you just overwhelm the model with irrelevant background details or too many tools. Like if your AI agent only needs to check your email and your calendar to book a meeting, but you go ahead and give it access to your entire Google Drive, web search, and 20 completely unrelated company manuals, it loses focus. You have to practice dynamic tool scoping. Only expose the specific tools and maybe the top 3 most relevant documents required for the exact step the AI is working on at that very moment.
Then we have context confusion. This is what happens when you dump 10 years of poorly formatted, unstructured historical data into the AI. The model gets lost and actually mistakes background reference material for a direct user command. The source provides this terrifying example, where an AI reads a past PDF that contains the text, "System shutdown." And because the data wasn't formatted clearly, the AI mistakenly reads that as a current instruction and, yeah, accidentally triggers a server reboot. No way you want that happening. You absolutely must use clear bullet points and structural steps to keep the AI on track.
Finally, context clash. Now, what's really interesting about this slide is seeing how an AI behaves when it's put in an impossible situation. If you upload one sheet saying your consultancy fee is $10,000 and another sheet saying it's $50,000, those facts clash. The AI has no idea what to do. So what does it do? It hallucinates. It might just invent a totally fake middle ground, saying the fee is, $30,000 just to resolve the conflict. Consistency across your context data is absolutely vital.
And that leads us to Section 5, the right memory framework, the ultimate solution.
So how do we actually prevent our agents from being poisoned, distracted, confused, or conflicted? How do we build that perfect digital worker? We use the right memory framework. Step 1, write to Scratchpad. Just like you or I would use a sticky note, give your AI a temporary space to jot down short-term thoughts so it doesn't clutter up its main memory. Step 2 is retrieve and select. Dynamically pull only the high-signal, highly specific tokens needed for the exact task at hand. Leave all the irrelevant menu items behind. Step 3, isolate tasks. Please don't give one single agent a 50-page job description. Divide large jobs among sub-agents, one for research, one for design, one for emails, and let a central orchestrator manage them. And step 4, trim and compress. Instead of giving the AI a 10,000-page book of company history, compress it. Use embeddings and vector databases to condense that history so the AI only pulls the exact paragraph it needs, precisely when it needs it.
By mastering these 4 steps, you protect that incredibly precious context window we've been talking about. You move way beyond the amnesia of basic prompting. And honestly, the most exciting part of all this is that with perfect context engineering, you don't need to write a single line of code to build an autonomous, 24/7 digital workforce that is tailored exactly to your business. The technology is already here, the framework is incredibly clear, so the only question left to ask yourself is, what will you build?